Hi, welcome to Mathematics with Tom. I am Tom, and in this video we are going to solve y triple prime equals t, and it has the initial conditions of y of 0, y prime of 0, y double prime of 0, and we're going to solve it using the Laplace transform. All right, here we go. So I'm going to start out by applying the Laplace transform to both sides of the equation. So if I start with y triple prime equals 2, I would apply the Laplace transform to both sides. That's y triple prime equals the Laplace transform of 2. And let's think of a constant. This is really the same as saying 2 times the Laplace transform of 1. Well, 1 is e to the 0t. And that might be, let's keep that idea in mind. So the Laplace transform of y triple prime becomes s cubed, y of capital Y of s minus s squared y of 0 minus s y prime of 0 minus y double prime of 0 equals 2 times, and then the Laplace of e to the 0t, well, this is times 1 over s minus 0, but that's kind of strange. We're just going to write that as 2 over s. And I'm going through that little extra because we're going to see it more as we go through this problem. So let's solve for y of s, capital Y of s. So I have s cubed y of s equals, now I'm going to move the next 3 terms to the right-hand side of the equation. So I can write this as s squared y of 0 plus s y prime of 0 plus y double prime of 0 plus 2 over s. And my next step will be to divide all terms by s cubed, and that will give us y of s. Y of s then equals, now when I take s squared y of 0 and I divide it by s cubed, 2 of those s's from the numerator cancel in the denominator. I'm left with y of 0 over s. And then the next one, I divide s y prime of 0 by s cubed. I get y prime of 0 divided by s squared. Plus, now I'm dividing y double prime of 0 by s cubed. Y double prime of 0 divided by s cubed. Plus, now I'm taking 2 over s. I'm dividing it by s cubed, or you could think of multiplying as by 1 over s cubed. This is 2 over s to the 4th power. Now, before we go on, let's do a recall. So let's recall. I'm going to write these anyway. Recall the Laplace transform. We've already used this of e to the at. We just said this is 1 over s minus a. But we're going to need some more. So let's use some other colors here. I have these pretty colors. So the next one is, what happens if you have the Laplace transform of t e to the AAT? Well, this becomes 1 over s minus a squared. Then let's grab another color, like this pretty yellow color. If I have the Laplace transform of t squared e to the AAT, this becomes 2 over s minus a cubed. And let's use we'll use this bright green the Laplace transform, one more, Laplace transform of t cubed e to the at, this becomes 6 over s minus a raised to the 4th power. And if you have this light blue, the general form is that the Laplace transform of t raised to the nth power e to the at, this is equal to, run out of space here, n factorial divided by s minus a raised to the n plus 1. And that's our general form. So let's begin. I'm going to work on all of these terms, and I wrote this so we can kind of color coordinate this as we go. And I'm going to use this squiggly arrow. I saw this. Arthur Maddox cleverly used this in the MIT Open Courseware videos. So if I want to transform y of s, or invert the transform, I'm going to use a squiggly arrow to say that that's the same as y of t. Okay. The next one I have is, now what I'm doing is I'm going through my terms. So the next term I have is y of 0 over s. And I want to, and before I transform that, I'm going to bring it down here. If I have y of 0 over s, and I'm going to do this once, is think of this as a constant, y of 0, times 1 over s minus 0. That doesn't change anything. Well, when I transform that with the squiggly arrow, well, what does that become? Well, 1 over s minus 0, that is very simply e to the 0t. So this just becomes y of 0 times e to the 0t. But e to the 0t is 1, and so this is y of 0. Now, the next one we have, and I'm going to match my colors, is going to be in this orange. And the next term I'm working on is this one right here, y prime of 0 divided by s squared. So y prime of 0 divided by s squared. Let's think of this as a constant, y prime of 0 times 1 over s minus 0 squared. Well, I purposely did this in orange, and I kind of used the wrong orange. It should have been this orange here. That looks much better. There we go. That matches down here. If we look at this box right here. So, and that's this transform right here. That's all we have to do. Well, this transforms then into t, or our constant. So that's y prime of 0, constant, and then times t e to the 0t. But we just said that t, or e to the 0t is 1, and so this becomes y prime of 0 times t. Now, I'm going to use yellow because I'm going to work on my third term. This third term, we'll do this in yellow. And that matches this yellow transform down below. So now I have y double prime of 0 over s squared. Well, before it becomes obvious, we have to do a little work here. Again, we have a constant y double prime of 0. Now, when we think of multiplying this, right now it's written as 1 over s minus 0 squared. But notice that the Laplace transform that we have in the bottom left in yellow, it has a 2. It has a 2 in the numerator. What I can do is I can multiply this by 2 over 2. This 2 in the numerator will go into the numerator for my inverse Laplace transform. The 2 in the denominator will stay along for the ride. It becomes a constant, and it looks like this. It looks like now I have, you could think of this as y double prime of 0 times 1/2 times, well, this is, oops, this should have been a cubed in the denominator. Cubed over here as well. Sorry about that. Times, this is going to become t squared e to the 0t. I had to think about that. Well, and e to the 0t we know is 1, and so we might more simply write this as y double prime of 0 times 1/2 t squared. Finally, let's go to our green term. And our green term is this one. It's the 2 over s to the 4th power. And we're going to use our green Laplace transform right here. I'll show you how this works. If I write, so here we are, 2 over s to the 4th. If I write this as 2 times 1 over s minus 0 to the 4th power, it almost fits. What we're missing is a 6. Well, let's just multiply it by 6 over 6. So now this becomes, this 6 in the numerator goes into the numerator for our inverse Laplace transform, and the 6 in the denominator is going to become the denominator of 2, so this becomes 2 6, which is 1/3 times, now look at this, this was t cubed, I'm looking in the parentheses, this is t cubed e to the 0t, or more simply 1/3 t cubed. And finally we can write our final solution, and that is that y of t is equal to y of 0 plus y prime of 0 times t plus a yellow term, y double prime of 0 times 1/2 t squared plus 1/3 t cubed. And that's how we would solve this third order differential equation using the Laplace transform. I hope that helps, and thanks for watching.